This conference will now be recorded.
All right, everybody, Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us today for the Satellite Book Club Seminar Series. We have reached session number 80. Great milestone today. Glad to see everybody on the call. Hope everybody's staying well. Title of today's presentation, NUCAPS Performance in Winter Ice, Sleet, and Snow Environments, the NOAA Products Validation System, or NPROVS. And our presenter is Tony Reale, physical scientist from NESDIS STAR, the Operational Sounding Product Development Branch. And we're glad to be joined by our facilitator for today, Pat Spoden, the Science and Operations Officer, the Weather Forecast Office in Paducah, Kentucky. Just a few reminders before we get started. You just heard the session's being recorded. There's going to be an opportunity for questions and answers after the presentation. So if you're from a field office or regional headquarters in particular, please post your questions in the chat. We'd love to field them in the order they are asked, including if you have any comments about this topic. We know it's winter season. There's a lot of winter forecasting challenges in front of us. We're also looking for future presenters on other topics. So if you have something to share, especially as we head into spring, maybe you have something to mention about severe weather prediction, we'd love to have you as part of the Satellite Book Club. And if you need training materials, or you need help locating training materials, Brian Mott, the Office of the Chief Learning Officer, can help with that. Just like to thank our Tower S team, particularly Kushad Bowman, Lee Byerly, the Office of the Chief Learning Officer, and the GOES-R and JPSS program for being with us today. Without further ado, I'd like to formally introduce Tony. Tony Reale joined NOAA in 1984 as a member of the Sounding Implementation Branch to monitor and develop improvements for TOVS derived sounding products, spending most of his career on derived satellite sounding development, analysis, and user support, including the implementation of the NOAA Products Validation System, or NPROVS, which became operational at STAR in 2008. Tony, welcome to the book club.
Okay, thank you. It's a pleasure to be here. And just like to review some of the backup I have, a tremendous amount of backup. My staff, Bowman, Mike Petty, Cassandra, and Charlie Brown. They're from STAR IMSG. We also work closely with the NUCAPS team. We are separate from them. We try to give them ideas on product performance, and then it's their job to try and get it in. A very complicated process. Also, all made possible here by the NUCAPS Sounding Initiative. Bill holds those periodically, and it's been a gateway for me to get some of this information out. And of course, you have to recognize Chris Barnett, the architect of NUCAPS, the original architect. Okay, next slide. Here's a basic outline. I'll talk a little bit about NUCAPS, a little bit about NPROVS, and then get into the ice storm case, which was on February 10th out there in Paducah. In fact, I had some of the information from their field office I used in this study, so you'll see that. And then we move on down to Nashville and the sleet snow case. Hours of sleet falling in Nashville. So we're going to take a look at that and how did NUCAPS do, and then I'll give you a very brief summary. Next slide. NUCAPS, you could spend a whole time just talking about NUCAPS, but basically they're derived from hyperspectral, infrared, and advanced microwave sounders on board NOAA JPSS, also EUMETSAT, the polar orbiting sun-synchronous polar orbiting satellites. Sounding products, nominal 50 kilometer, 1 kilometer vertical resolution. This is highly, highly optimistic. This is the sensor. The products are not so highly resolved. Temperature and water vapor profiles up to 50 kilometers are produced. Typically, users aren't too concerned, at least these users above 10 kilometers. And I might mention that the density of products distributed to users is 250 meters, far oversampling the sensor capability, and that's what the users want. That's what the users get. They're global, twice a day over most locations of the Earth, about 250,000 soundings per satellite per day. That might actually be per 12 hours. I have to check that out. And they were used by forecasters over the direct readout system. typically for pre-convective severe weather summer applications. So this is a new area. Not new. Scott Lindstrom and his group do a lot of work here, and they're looking all the time. A big step in the process is the cloud clearing, and I will point to that. Because of it, we get up to 70% global coverage of the IR plus microwave soundings that the users need. I will also show a case or two, but keep in mind all the products really look very much like the a priori guess, particularly from the profile shape structure. We have 2 satellites, morning satellite, 2 a.m., 2 p.m. We don't look at the MEDOP because they're not available on AWIPS 2, but some of the direct readout people are using the MEDOP satellite systems. And yeah, I'm sorry for this. The operational system was upgraded in July 15th. I had a choice of showing the original, I'll call them version 2 operational, or go and show the test system, which became operational on the 15th. Now I am emphasizing the test system. And one of the reasons, even though it was not operational at the time, it clearly looks a lot better. So I'm going to emphasize that, and that's good news for the product team. Okay, next. I won't go much into this, but this is the source of all our data. The orbital data I show are coming from the NUCAPS, which are coming over the mainframe computers. There's also the test system coming from ASSIST that's getting in here, and I will be part of the presentation will be comparisons against RAOPS, and part of the presentation will simply be looking at the so-called orbital or granule data from the NUCAPS. Okay, so this runs 24/7. This is what we implemented in 2008. Next. Okay, so let's get to the case study. So the first case study, and Paducah somewhere. This was from the Paducah office, actually. There you go. Freezing rain event and peaking in this area of Indiana, Illinois, Kentucky. It's like 5 states coming together here. And we looked for these 2 locations to see if we had any NUCAPS. And the reason they're up there is because I'd already looked and I know they're there. So we're going to look at the freezing rain event, and this freezing rain event mainly was on February 10th. So we're going to look early, the 2 passes of the NOAA satellite, the morning pass roughly 2 a.m. local and 2 p.m. local are the times of the satellite passes. Okay, next. So keep in mind on this 2, again, this is just basically the ice storm setup. Strong Arctic air mass was already in place. Temperatures were below freezing. And this cold Arctic air mass is a problem for NUCAPS because it's getting colder as you go down to the surface, and air is heavy and it sits down in there. Okay, so yeah, this is their report. But the bottom line is there was widespread ice accumulations. This quarter to half an inch rainfall, ice rainfall, very close. So we're going to go look and see. And surprisingly, with all these clouds, we had IR plus microwave retrievals for NUCAPS. Next. I refer to the IRBS. Here's a look at the situation. And when you have freezing rain, you don't have much going on. It's basically zonal flow with a little bit of movement upward. There is low developing to the west here. Here are the 2 locations the morning of the 10th, and I highlighted in red freeze line. So you can see the freeze line is right now, these 2 sites are below freezing at 850 hectopascal. Go to the next slide, which is the afternoon of the 10th, and you can see things moved up. So the question becomes, A, what do we see initially, and are we sensitive to the warming aloft that is changing the precip from a predominantly sleet, snow to a freezing rain? Profiles must look a certain way. So if you go back and forth there, basically, do we see this movement? Next one, do we see this movement? So we go to the next slide. How sensitive are the NUCAPS here? So now I show it again, and there's no RAOPS. So RAOPS not going to help us. In fact, right now it's raining big time, and I'll show that later because I do go to Tennessee in the next. So we're up in here. We're by ourselves. We only have the data that's available in our processing, which does include the European Center analysis. So we go to the next slide. This is the only slide of cloud clearing I will show. These are all the fields of view for the MPP at 7Z in the morning and the NOAA 20 at 8Z. NOAA 20 comes about an hour later in overpass. Now, NPP is no longer available, but back in this study it was, and the products from NPP were as good as the products from NOAA 20. They paralleled very well. Here are the NOAA 20 operational cloud clearing cases on the bottom for comparison. You can see for the most part there's good agreement, except the operation is failing, claiming that these are, you can't even do microwave retrievals in the red. But all in all, pretty good. But the point is, most of them are yellow, which means the cloud clearing did not produce. You have to live with that. This is the catch for the user. So we will look at the catch for the user. Next slide. So what I've done here is I'm just showing on the early morning of the 10th, the situation using the NPP test at 7Z for temperature on the left and the NPP and the NOAA 20 test on the right, two satellites being compared that I know are consistent. So I'm showing you two different satellites, two different overpasses, two different distributions. This is what the user sees. And I'm going to differentiate the northern point as the Y and the southern point as the X in the following slides. So if you go to the next slide, this is the early morning and the afternoon. You can go back and forth, right? So you can see from the early morning of the 10th to the afternoon, it actually got a little bit warmer. And the moistures are also moving up according to the analysis, and you can go back and look at these, but if you just settle on this, there's fairly good agreement, even though there's a lot of space in between them. You've got the drier air to the north, right? So now let's go to the afternoon of the 10th, right? Things getting warmer, moisture pretty stable, not much happening, but there was a little bit of warming. And then go to the morning of the 11th. Oh, I'm sorry, go back. I'm in the wrong case study. Go back to, right. So what we're going to do is we're going to look at soundings, first at the Y location for the morning and the afternoon. And the soundings are going to be shown for each one of these systems. So you're going to see the vertical profile of the model, the NUCAPS test, the NOAA 20 test, and the model, both at 18Z. Right. You're going to see each one of these sets. Okay, so go to the first set, and we can see that the NPP profile, certainly a snow profile. This is the freezing line. And the NOAA 20 test, very similar to it. The model, on the other hand, shows this little bit of warming here. This is a 3-kilometer layer, so it's relatively thin from what the sensor could see. And then from 0Z to 6Z, it moved in these directions, and these two in the upper left, lower right should look similar. And in my humble opinion, they do look similar from the point of view of the cloud tops and the overall shapes, but the NUCAPS just a little too cold. But what happens in the next slide, 12 hours later, you can, if you just go back and forth, you can see that, go back, you can see that the NUCAPS definitely warmed, consistent with not only the visual, but also with the model. The model's also showing warmer, and now there's clearly a rain and a freezing rain event going on to stay at that last one. And you can see as you go from 12Z to 18Z, the model, yes, stay on the 18Z. Next one. Yeah, the model has gotten warm. According to the cloud clearing, there was no product made here because it was contaminated by precipitation. So we're really believing there was a lot of precip going on. What's interesting here is that the 18Z, I'm sorry, I didn't put, this is the 19Z, NOAA 20, but they didn't have one, so you don't really need it. Not enough, but good movement. I'll go to the next case. And this is the starting point of that second point, also in the red, a little bit to the south. And here's the starting point here, before the warming, early morning. Here are the European center profiles. the cloud tops, these are quite a bit different, but when you go to the afternoon pass, which is the next slide, again, now the NUCAPS went too far. It's too warm in this layer, but it's very close and it's very competitive. And given the global forecast of this system, this really puts us in the position to say we're tracking it. We see it. There's just a few degrees off, just a few degrees off. And you can see this is clearly freezing rain profiles. So I give NUCAPS a very good grade here because it is probably correctly reflecting what the sensor is showing it. It cannot see the coldness of the lower layer, especially if it's inverted. And this inversion simply isn't going to get picked up. So it's very good, very good. All right, let's move on. So that covered the ice case. So I then moved on to the sleet case. Now this is the February 14th for the Paducah domain, but I decided to move everything to Nashville. So you go to the next slide, right? And now we're going to cover the state of Tennessee, and we're going to focus in on Nashville's major sleet event here. This is very high amount of sleet falling. And this occurred in a stable environment. So things weren't changing much. There's not a great penalty for time in some of these assessments, and you'll see why I said that. But we're going to focus late on the 14th to early on the 15th when the bulk of this sleet fell, and then cold air pushed through after that, and it turned to snow, and we'll see that as well. And we'll look again, similar to how we did it before, first look at the bigger picture and then go in and this time deep dive to the Reale location. We now have a ground truth. So we go to the next slide. Again, here's the prog, and I talked about it before. We're going to check this out, late 14th to early 15th. And next. Here's the weather map. So here is evening of the 14th. Here's the freeze line. Here's the Nashville. You go to the next slide. Everything's warming. The atmosphere is going from a snow atmosphere to a sleet atmosphere. Do we see it? Do we see this warming? So go back to the next one and then go to the next slide. You got this nice counterclockwise motion, lows coming through. The freeze line is moved through. The cold air is coming. It's now a snow environment. What do NUCAPS look like in these environments? Next. Here's the Nashville Reale. We love it. Next. They fly twice a day. So now I've got the pattern over the Nashville Reale. Same as I showed before, temperature and moisture. You can see there's good alignment between the analysis, which are now pinned to be the closest analysis to the time of the satellite data. So we have 6Z, 8Z, 6Z, very close. And you can just tell there's good agreement. I mean, we're certainly not quite as cold up here. And again, it's hard to get that cold lower layer. I didn't look up here. I could look up and see what was happening there. But certainly a deal of moisture coming in, a little bit of moisture to the south. This was like morning of the 14th. So now I'll go to the afternoon of the 15th. The first thing you'll notice is this little cold pocket of air developed in Kentucky. This goes away in the next cycle. And sometimes I wonder if the European Center missed this. I'm not sure. But anyway, pretty bold to be saying that, but it's happened. On this particular day, there's no RAOPS for NOAA 20, but there's plenty of RAOPS for NPP test. Why does the hour make a difference in the cloud clearing is a very good question we'll look into, but it seems like the NPP is letting some in. And later I will show that some of even though the IR plus microwave failed, when you look at it, it looks fine. I'm going to show that. So it's very interesting. And here's the corresponding 18Z in the afternoon of the 14th. And then if you go to the morning of the 15th, two things are happening. Here's the low developing. And if you go back and forth, you'll see the progression of the warm air. Go back to the next one. This is exactly what we saw in the analysis. And then you can look at the moisture as well. It's starting to move into more moisture. and warmth. They're correlated. And so the freezing rain event is got a lot of rain falling through it. So you're getting an inch or two of rainfall, I believe, through this period. Next one. And then the turns to snow, the freeze line, and I'll show you that in a minute, now is through. It's now a snow event, still snowing. And the moisture, of course, is moving along. The low is going to come up. And I forget what happened to this afterwards, and that's not important. Okay, so now let's go and end off with the deep dive. So go to the next slide. Oh, I'm sorry, this is early morning on the 16th. So go back and forth. It really clears through. That's right. I had this case study. If you go from the 15th to the 16th, boom, it's in, and it still might be snowing here. We'll let you decide. Okay, so now go beyond the 16th. All right, everything's tracking, by the way. Go back, look at Nashville and the snow event, and we're going to focus on Sunday evening the 14th into Monday the 15th, just according to the guidance that we got from the Paducah report. Next. Okay, so I'm going to start off on the 10th. The 10th was when we did the ice storm. As you can see on the 10th, there's plenty of rain. Temperatures, this is the freezing line again, 273 line. It's all rain, right? It's all rain. This is the NUCAPS test. I've also shown the NUCAPS first guess as the light green, and you can't see it because it's the same as the test. Most of the shape and the profile structures come from the guess. A little bit of difference up here. The guess started out and was actually the retrieval made it a little drier. You can see the forecast always follows the rayoff. So I won't show the forecast anymore. I won't show the guess anymore because they're basically being shown without you plotting them. So this is early morning on Saturday, but on the 10th. Now let's go to the day of the event. This is the 14th, and go back and forth, right? Back to the 10th and forward and stop there. This layer is a very difficult layer, and you can see this is what the frog talked about. The cold air is coming through. If you go back to the first one more time, you can see that everybody moves. However, the agreement down at the circle, now go to the next one. There's certainly movement of the profiles all in the right direction, and the moistures are looking good, but we're missing it right in this layer, this 1 to 2 kilometer layer. And with the current hyperspectral sensors, you're just not going to really get a pin on this. But you can see that the NUCAPS test does a better job than the NPP, which is the operation in this case. These profiles are 3 to 4 to 5 hours apart. That's the bad news for assessment, but as a user, you're getting additional information that is not redundant with the information you already have. And I must point out, NUCAPS are observations, they're not models. And there's a big difference. Observations have a value about them that you may not have in the models because they're observations, so they're unique in that fashion. All right, let's keep moving now. Late on the 14th, not much is changing. This is a sleet event. It is now sleeting. So these are sleet profiles. And you can see one thing of interest, the cloud tops, fairly consistent. This is the NPP test and NOAA 20 test systems. But what's interesting is the dark line for the test actually failed the cloud clearing. But from the point of view of carrying information, it's very good. So we, for example, would point this out to the NUCAPS team and see what's what. Okay. So then we're going to go to the next one, which is the morning of the 15th. It's still a sleet event. Things got a little warmer. I would have loved to have seen the profiles. Go back one. And then come to the next one. The profiles did not get warmer. In fact, the shape changed a little bit. But you can see both of them are attempting to get the cold air. The NPP test is the light green. An hour later, the NUCAPS NOAA 20 test. Again, an IR plus microwave that, according to the retrieval, failed. which means the solution did not converge. However, it looks good. It looks good. It actually, you know, and almost you'd say an hour later, things are getting colder. Maybe that's better, but that's far too far to go with this. But the point is, we are getting the structures, and this is a difficult and will always be difficult. How close you get to this, I mean, the idea that we're moving out up here has everything to do with the fact that it's trying to make it colder in here. And we have to solve radiances. We're not solving temperatures. The radiance profiles of these profiles probably nicely satisfy the radiances you would compute from the red profile, but the shapes are different, and the shapes are outside in many cases the sensor sensitivity. Okay, next. Here's the actual big snow. No, it's now too much to do cloud clearing. This is the point, the evening of the 15th, we believe it changed into a snowstorm, but the clouds were too much, and in some cases, even the microwave were failing. So you have nothing from the NUCAPS here. Go to the next one. Now the cold air has come in. This is the morning of the 16th. Everything has shifted over, and if you go back 2 slides, and then you go forward 2 slides, just watch the progression of the green. One more. Everything is shifting. The NUCAPS are all moving, but it is having a hard time with this layer because it doesn't really see it. It doesn't really see it, but it's got information enough about what's going on above the layers to really be trying to mimic it. In this case, an hour later, NUCAPS test, which once again failed the QC, looks very good. Very good, and it is getting colder through this period. I don't think an hour produced this much cold, but it is in the right direction. So the point is, we're picking up information, and in some cases, maybe that information isn't clearly getting to the user, but maybe there is really something intrinsically wrong with these failed NOAA 20s that we're not seeing with this relatively simplistic assessment. Okay, so to finish up here, I hope you have some questions because I'm sure that not everything was clear, but we did provide a systematic assessment of the ice case and the sleet case. Never gonna do I don't think I'll ever find another sleet case like that. And then the snow case. So we used the same approach. One with the ice case did not have Reale. One with the Nashville did have the Reale. So we're able to do different types of things. At the end of the day, we saw good representation of the synoptic environment. Very interesting, the NUCAPS which passed the IR, meaning the solution converges, are evident despite an abundance of lower layer cloudiness, where we're pulling up IR-based retrievals in regions where you had to clear them. And the answer is that probably double even the amount of data you got, particularly for the snow case. It seemed that the clouds detection was less able to get past with the ice case relative to the snow case. The cold layer, lower layer, Arctic estimated systematically underestimated for NUCAPS, but that is consistent with the sensitivity of the sensor. NUCAPS is responsive to changes. Very, very important. You hit the nail on the head, but you got to be in the ballpark before you aim for the center of that target. And NUCAPS is clearly in the ballpark, NOAA 20, NPP, and I imagine the MEDOP as well. And of course, I didn't really show this much, but in doing this, I'm clearly aware now that the test currently in the operation was performed better than the old operation, at least for these cases. And we were able to get this system through the test facility, the test data provided by ASSIST. So we're set up to do that. NUCAPS potentially useful in a winter environment is clear. And I stop there.
Okay, thanks, Tony. Just want to make sure that everyone has the opportunity to stay on. participate. We got a little bit of time for questions and any discussion. We're also going to share in the chat room short survey form. So take that if you can. Just to remind you that a week from today, on Thursday the 20th at 12 Eastern, we have Dr. Connor Nelson, research scientist from CIRA and satellite researcher and GOES liaison with the Operations Proving Ground in Kansas City. We'll discuss the impact of satellite data in mesoanalysis. Very interested in that, and results from the 2021 OPG real-time severe weather experiment. If you want to, or you have any good information that you want to present, contact the TOWS team. Lee Byerly or Kashaw Bowman questions, they'll help you. And right now we'll go ahead and do any questions. If you want to verbally ask them yourself, let me know in the chat room. Otherwise, we'll follow what's in the chat. So our first question comes from Bill, and he wants to know, how quickly can the soundings be available? I assume that's an AWIPS.
Oh, well, I know AK is on the line, right? I'm gonna let him answer that pretty quick. Direct readout, of course, instantaneously. AWIPS, 30 minutes. AK, are you there? Maybe he left. Is that Bill who? Bill Schoberg? No.
Yeah.
Okay, Rebecca says it's an hour.
Okay.
Yeah, right. That's a good question. So they're a little behind. Yeah. A lot of times we're using these data, however, to predict something in the future, particularly with the convection. Okay.
So while we're waiting for other questions, is this data being used in the model and in the models? Are they taking in this data?
The answer to that is no. And again, I'm not clear of all the applications, so perhaps Rebecca or Emily Burnt, who are more involved with how this data is used, they may actually be using them in model runs, but this data back in the 90s was used as the sounding products, but no. Right now, and I hear see Rebecca again, level 2 is not used in any model, certainly not formally. But of course, it's used by the field offices who are trying to use the model data plus any other information they could get to warn the public, or at least understand what might happen.
Okay, super. Didn't see any other questions. What about what's the typical horizontal and vertical resolution of NUCAPS?
Oh, okay, so we again, the horizontal resolution is nominal 50 kilometer, but it does change as you move further from the native view. So it can go up to 150 kilometer horizontal resolution at the native view. The vertical resolution is a big topic of interest. That becomes profile dependent. So if you have a simple profile with a dry adiabatic lapse rate going up to the tropopause, and you're going to get excellent 2 kilometer resolution. But typically, I would say the vertical resolution is 2.5 to 3 kilometers, and probably degraded even further if you have these inversion type atmospheres in the lower troposphere that are simply going from a cooling lapse rate to a warming lapse rate to a cooling lapse rate, and that just creates a void in the sensor sensitivity, so you don't see that. So it's a very difficult question. The NUCAPS are distributed at a roughly 250 meter vertical density, and that way oversamples the sensitivity, which is why when you get down into those lower layers, you really can't expect the NUCAPS to be right on top of that. Now, if you had a model a priori, that would be different, but the NUCAPS a priori are independent for the most part from any forecast model. So it's a loaded question.
Okay, well, yeah. Bill also wanted to make sure that everyone knows that you have gridded NUCAPS data available in AWIPS and on the Real Earth website. So it would be interesting if anyone's on who's used to use this operationally and has a comment about it. Okay, so Scott said he's looking at his AWIPS right now, 1735, and the 1525 passes in. So yeah, so generally within an hour is what we're seeing with the, so that's pretty good.
Yeah.
In reality, when you send up the RAOB, you're waiting an almost an hour to get
Right.
that as well. So
Right, and of course the RAOB's giving you this measurement that's varying over time at each level, which I didn't mention, but that also comes into play in these assessments. But when the atmosphere is relatively quiet, synoptically, as was in the cases, both of these cases, there isn't as much drift and there isn't as much variability. So even over time and distance, but there is enough.
Yeah, and this again, you know, Bill wants to remind everybody that NUCAPS is very valuable in the pre-convective environment. And I think that's what most people use it for in the operations side that I've seen. Like to look at that and get an idea. Again, the trends are important. Where's the warm air, dry air? Okay, so Jordan says that there are also aircraft profiles that you can compare in some locations. So some of that's available as well. Lots of comparisons.
Yeah, I mean, there are airs in the MEDOP.
So have any other last comments or questions? If not, I will turn it back to Jordan for final remarks.
All right. Thank you, Pat, for facilitating today. And thank you, Tony, for your presentation. I also want to note, Pat, I think most of your colleagues from the Weather Service know, but perhaps not everybody from NESDIS knows. You had a great segment on 60 Minutes explaining the warning process and the impact of the Mayfield tornado. And I know that's a harrowing task when you have significant tornadoes go through your forecast area. So very nice job. I was impressed by your service and your interview, and also for those of our colleagues from NESDIS who may not have saw that interview, encourage you to check it out on YouTube from a 60 Minutes episode, I believe, that aired in December. So thank you so much.
Well, thank you. I appreciate that. They did a really good job. They were very professional.
That's great to hear. All right, so as already been mentioned, we are going to continue our satellite book club next week, Thursday, January 20th at 12 noon Eastern time. Once again, Connor Nelson from SERA is going to be talking about the impact of satellite data in mesoanalysis and results from the 2021 Operations Proving Ground Severe Weather Experiment. As always, if you need any assistance with the configuration of satellite products, if you're interested in NUCAPS, maybe you're uncertain about how to access it or have ideas for how NUCAPS could be displayed in AWIPS easier or more efficiently, please get in touch with Lee Byerly or Krishad Bowman. We're willing to help you. We're also willing to hear your feedback. We want to make satellite products as easy to use for you as possible. So let us know what your thoughts are on that. So we'll wrap it up there for today. Once again, thank you to our presenter, Tony Reale, and our facilitator, Pat Spoden. Hope everybody out there is staying well, and you'll join us again next week. Take care.